This is Hao Xiangjiao reporting for Lab 1, and our topic is constant velocity. So the purpose of our lab is to compare the motion of a moving object to the simulation by the computational model, and we'll discuss the comparison result based on Newton's second law. The law basically states that the external force added on an object is equal to the rate of change of momentum along with the time. And you can see in the formula that the change of momentum can basically refers to the change of velocity due to the magnitude of the net force. Interestingly enough, in our experiments, we can also apply to first floor, since our net force is designed to be zero. And here is our setup. Our object is the marker, and we will observe its motion along with the ruler. And we assume that the friction caused by the whiteboard is zero. And since the support force from the table is equal to the gravity, we assume that the net force is zero. And this is the experiment video. And so to check our motion, we use tractor to analyze the marker frame by frame. And we pull out the data by manually assigning the mass center of the marker. And we come up with this set of data. And in the end, we roughly calculated that the straight line will show in the bottom that the velocity of the marker is roughly 0.3 meters per second. And to simulate this experiment, here is my code I wrote for the scenario. So in our program, we update the scene in a while loop. And in this part, we basically apply to the Newton's second law by assigning the change of velocity to the position. Well, velocity is unchanged due to the zero net force, while the position changes due to the constant velocity. And here is how it runs according to the graphs. And so we compared these two sets of data, and we found out that they are actually pretty closing, that the experiment and data sets is really matched with the perfect model data sets. So we conclude that the net force acted on a pen is equal to the rate of change of momentum along with time. It's zero, and the velocity is basically constant. However, we were also faced with the limitations during the experiment, and one obvious one is the whiteboard. Because of the uneven surface, you can see that the marker starts to step back in the end. And that's the concern we need to tackle with. And to deal with it, we check the start frame and the end frame along in the middle where the marker is in constant velocity, so we minimize the impact of the uneven surface. And I believe we should also increase the frame rate in the camera in the future if possible, because in this way we can collect more data that can come out with a better estimate of the velocity of the marker. And in the final what-if questions, say if we trace the video in a negative direction, I believe that the result is still the same, because we are discussing the change of momentum, which is the velocity that is a magnitude that won't be necessarily influenced by the positivity or the negativity of the direction. And that's the end of the video, and I hope you enjoy. Thanks for watching.